Hello my dear students, welcome back to my class. In the series of learning programming in C, in the previous video we have discussed about pointer arithmetic. We have dealt with addition, we have dealt with subtraction. And today's class we will discuss about pointer increment and decrement. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Pointer increment and decrement. We have seen how to use the normal increment and decrement operators. Increment operator increments the value by 1 and decrement operator decrements the value by 1 by default. And we have seen how to use these operators. Please do check out the playlist of C language. You will know how to use increment and decrement operator. And I have also discussed about the prefix and postfix increment and decrement operators in separate videos also. Please do check the playlist. So we know how the prefix and postfix increment operator works. See, those who are watching this video for the first time, it's better to watch the increment and decrement operations first and then watch this video. Then you can easily understand what is this increment and decrement with respect to pointers and how the prefix and postfix increment decrement with pointers works. So now what we'll do here, we will see how the increment and decrement operators can be applied on pointers. Can we apply increment and decrement on pointers? Then how it has to be done? All those things we will see with small examples. Now here in this small code, we have an array. And the array is initialized with all these values, and here I have written the memory representation. So let me take it a 16-bit machine and we have taken the 2 bytes representation. So the values are initialized like this. And when I say the array name will hold the base address. So what is the base address? So it will be pointing to the location 100. It will be pointing to the location 100. So the array name will give you the base address. So what is base address? It is the address of the first element in the array. So what is the address of the first element? It is 100. Right. So that is held in the array name. Now what I'll do? I'll say int asterisk p. A pointer variable. So we have a pointer variable. Well, pointer variable will also have some address. Let me say it is 500. Now what I'll do? I'll say pointer P, pointer C. Here when I use the asterisk, I have told you in the previous videos also. So when I use asterisk symbol here, it is treated as pointer variable. But when I use asterisk in the assignment or while printing the values, it represents value at the location. So that you must know. Asterisk, when it is used in the declaration, it represents that it's a pointer variable. It tells the compiler that it is a pointer variable. But when I use this asterisk in the assignment, in the initialization or while printing, it represents value at the location. It acts as indirection operator, dereferencing operator. I've told this many a times while explaining pointers. Make a note of that. Okay. So now I'll say P equal to, I can write ampersand of a of 0. This is also fine. Or I can write P equal to the array name A. Both are one and the same. So let me write in a simple way. I say P equal to A. A means array name which will give you the base address, and that base address will go to the pointer. Now P will have 100. In the sense this pointer variable is also pointing to the base address, that is the first element. P equal to A. This is not allowed. A equal to P, because you cannot store a pointer value into an array, because array is also this array name is also pointer, but it is constant pointer, because constant pointer always points to the base address. You cannot change it. So hence we use this pointer variable so that we can traverse from one element to another element. So now what I'll do, I'll just say P plus plus. So what happens when I say P plus plus, you all know it is nothing but P equal to P plus 1. P equal to P plus 1. And what is this P plus 1? We have studied in the pointer addition. P plus 1 is nothing but P plus 1 into size of the data type. So if I just take the size of the data type as 2. So it is P plus 1 into 2. So what is P? P is holding 100. 100 plus 2, it is 102. So what is the new value for P? It is 102. Now the pointer P is pointing to 102. It is pointing to 102. Means P plus is an increment operator. Increase the value by 1. So it is P equal to P plus 1. Increase the value by 1 and store that value into, that is, you have to reflect that. You have to store that changes in P. So P plus 1 means what is plus 1? It is nothing but into size of data type. Size of data type, it is integer, so it is 2. If I take 16-bit machine, or if it is 32-bit machine, I have to take 4. Let me take it as 16-bit machine. Okay, so it is 1 into 2, so it is 100 plus 2, it is 102. So now I am just moving forward. Plus means I am moving forward by one element. From this one element means the element is 20 and the location is 102. So now the P is advanced. The pointer is advanced to next position or next location, I can say. So now if I just say, so what I'll do, if I just say printf %d, I say asterisk P. So what will be the answer? P plus plus means increase the value by 1 means advance the pointer by one location. P equal to P plus 1. So it is going to the next location. Value at that location. Now observe, asterisk used when in the declaration, it is to represent that it's a pointer variable. To tell the compiler that it is a pointer variable. Asterisk when used in the statements or it may be in the initialization and all, it will be acting as value at location. Value at location. So what is the value at this location? Asterisk. What is P? P is 102. What is the value at this location? It is 20. So if I just say print asterisk P, it is going to print 20. Okay. Now let me change the statement. Let me incorporate some prefix and postfix increment and decrement and we'll see what happens. Printf %d, then I'll say asterisk P plus plus. Now observe this carefully. I'll say asterisk P plus plus. If you write it in brackets also, well and good. If you don't put brackets also, no problem. If you just say asterisk P plus plus, then also it is fine. You can write it like this also. Asterisk P plus plus. Both are same. See, in some competitive examples, they may write it like this, they may write it like this. Both are one and the same. But if you write it like this, asterisk P plus plus, this is different. Asterisk P plus plus, asterisk P plus plus in brackets, both are same. This is different. Now we'll see what is the difference here. Look at here. Asterisk P plus plus. And just observe what kind of increment operator it is. Operator is next. So it is postfix. So it is postfix increment. Postfix increment, that what I am using with respect to pointer. Pointer, postfix increment. So postfix increment and asterisk according to the operator precedence. We have done a separate video for operator precedence also. Please do watch that video. You can easily understand the hierarchy of the operators so that you can easily evaluate the expressions. Okay. Based on the precedence of the operators, asterisk and plus plus is having the highest priority. But here this plus plus and asterisk, when I say it has to be in the evaluation process from right to left or it may be left to right. But here what happens? This is postfix increment. This is postfix increment. Post says you do the incrementation afterwards. You do the incrementation afterwards. So it will take the P value. So what is the value in P? Postfix increment says you do the incrementation afterwards. Pointer incrementation afterwards. Take the value of P. What is the value of P? P right now it is pointing to 102. So it says, what it says, let me evaluate this. Now, it is postfix increment. I say you do the incrementation afterwards. But take this P value. So what is this pointer value? So pointer value it has to take first. Pointer value is 102. Right? It says asterisk 102. So what is the value at 102? It is 20. So here for this line also what will be the output? So P was initially pointing to 100 here. Then I say P plus plus. Here if you just say before incrementing, if you try to print asterisk P, what it will print? It will print the value at 100, it is 10. If you have some printf statement here, it will say asterisk P means 10. Then if you do the increment, then it will say you advance the pointer, it will go to the next location. Then it says print the value at that location. So here the answer will be 20. Come to this point. Asterisk P plus plus, you have postfix increment. Post says do the incrementation afterwards. So you take this pointer value. What is the pointer value? It is 102. Right. So it is pointing to 102. Asterisk 102 means value at this location. Again this line also prints 20. Then it will do the incrementation. After that incrementation will be done. So P will be advanced to next location. So it is P plus plus means P equal to P plus 1. So it is going to advance to the next location. Again advanced by next location. So here the P value will be moved to the next location. It becomes 104. So now the P value is changed to 104. So now P is pointing to 104. Fine. Now after this, see in this line it is going to print 20. Right. So asterisk 102. P value is what? It was 102. Value at 102 was 20. It is going to print that. Later P value will be advanced. So P value becomes 104. Now I'll say printf %d new line asterisk P. What is P? 104. So it is pointing to the next location. So asterisk P means value at that location means for this line the value will be 3. Right. This is postfix increment with pointer. Now just observe one more thing. I'll say printf %d. Now what I'll do? I'll say asterisk plus plus P. What kind of incrementation? This is prefix incrementation. So this is pointer prefix incrementation. I say plus plus P. So plus plus and asterisk. So now when the compiler comes to this point, it is going to observe what type of incrementation it is. So here it takes the prefix incrementation. So prefix means incrementation has to be done first, first. So here what happens? Incrementation of the pointer will be done first. So it means to say P is going to be advanced to the next location. So now P, after this P was 104. Now it gets advanced to the next location. Now P value becomes 106. So now it is pointing to 106. Okay. Do the incrementation. So here it means to say asterisk 106. Observe this carefully. Here it was asterisk P plus plus. It means to say it was asterisk, take the original value of P, it took the original value, it was 102. So asterisk 102 means I got 20. Then P gets advanced. So P will point to 104, next location. It becomes 104. So when I say asterisk 104, I get 3. My answer is 3. My answer is 20 for this. And here also 20. But what about this? So right now P was pointing to 104. I say plus plus P, asterisk plus plus P. It means to say you do the incrementation of the pointer first. Incrementation of the pointer first means pointer has to be advanced. 104 4 it was, it will move to the next location by one element, means 106. Now P is pointing to 106, asterisk 106. Asterisk 106 means the value will be minus 4. Got it? So hope you are understanding this. Asterisk P, asterisk plus P. So it is asterisk 106. So what is the value at that location? It is minus 4. And in the next line, if you say, try to print the value of asterisk P. So P will be 106. Once again, I'll get minus 4. So hope you have understood with this increment, prefix and postfix. Now let us see the decrement operation. So P equal to A. As usual, I am storing the base address to the pointer. So now P is pointing to A. Now I'll say printf %d. I'll say asterisk P minus minus. Okay. So what kind of decrement it is? It is postfix decrement. It is postfix decrement. And this pointer postfix decrement says you do the decrementation afterwards. Okay. Do the decrementation afterwards. Now, what is the value of P? So it is postfix decrement. As it is postfix decrement, decrementation will be done afterwards. What is the value in P? It is 100. Okay. So it means you say asterisk 100. Value at the location 100. So for this line, my answer will be 10. Okay. Later what I'll do, I'll say printf %d new line. It's a postfix decrement. It says do the decrementation afterwards, but you fetch the value from this location. P is holding 100, fetch the value from that 100, means it is 10. Then you do the decrementation, means you get backward by one position. So when you get backward by one position, of course memory will be there. But what is the value there? So you get some junk value. And if you just try to print asterisk P now, P will be decreased. After fetching the value, then the decrementation will be, because it is postfix. Decrementation will be done afterwards. So then the decrementation will be done. It will go 2 bytes backward. Again the same thing. You say P minus minus means you should know this. It is nothing but P equal to P minus 1. Right. So it is P minus 1 into size of the data type. It is 2. So it is P minus 2. So P is 100. 100 minus 2. It is 98. It is going backward location 98. What do you find here? You find nothing. You may find some junk value. And if you say asterisk P, so P is pointing to the backward location, means P is pointing to 98 now. It is pointing to 98. What do you find there? Nothing. So you may get some junk value. Okay. Fine. This is what with this. Now let us know the prefix decrement also. So for that what we'll do, let us point the pointer to some other location. So what I'll do now, let me change this value. So what I'll do, we have a pointer variable. So let me say P equal to ampersand of A of 3. Okay. So store the address of A of 3. The location 0, 1, 2, 3, 4. A of 3 means it is 106. P is pointing to 106. Okay. Now I'll say printf %d. I'll say asterisk. Let us see with prefix decrement. So it is minus minus P. Fine. You can write it in the brackets also, no difference. Okay. Now what I'll do? Now asterisk minus minus P. Now this is prefix decrement. Prefix decrement says you decrease the pointer value first. Means you do P equal to P minus 1. Means you get backward by one position, by one element. So now P is 106. Get backward by one position means it is P equal to P minus 1 in the sense P minus 1 into size of the data type, P minus 2. What is P? It is 106. 106 minus 2, it is 104. So now it is getting backward by one element. So it is pointing to 104. So now P is pointing to 104. Then it means to say, see, prefix decrement. This is prefix decrement. So what is this prefix decrement says? You do the decrementation first. So we have done it. So it is 104. So what is the value at the location 104? So it is 3. So the answer for this line will be 3. So hope you have understood with this prefix decrement. Let us have some complex statement. Let's try to analyze this. Printf 3% t. I say minus minus p means it is prefix decrement. Asterisk minus minus p. Prefix decrement. And this is postfix decrement. And this is prefix increment. So when you have the statements like this, so it is going to evaluate from right to left. From right to left. So this one has to be evaluated first. So as it is postfix increment, you can write it within brackets also. You can just say asterisk plus plus p. That in that way also you can write it. Now what I'll do, plus plus p, it is prefix increment. Prefix increment means I need to do the incrementation first. So what is the value of p? I am saying that it is pointing to a of 3. So let me write a pointer here. So p is a pointer. P pointer is pointing to the location a of 3. What is a of 3? It is 106. Fine. So p is pointing to 106. Now when I say prefix increment, incrementation has to be done first. So p gets advanced to the next location. It will move forward by one element. It will go to the next location. So what is the p value as it goes to the next location? Plus plus p means p equal to p plus 1. I have told you. So what is plus plus p? It is p equal to p plus 1. So p is at present 106 plus 1 into size of data type. So 106 plus 2. So it is 108. So the p value is changed to 108. Okay. So what is the p value? It is 108. When I say asterisk plus plus p, asterisk 108, increment, do the incrementation first. That we have done. Then fetch the value at that location. What is the value at the location? So it is pointing to 108. So when I say asterisk 108, it is going to print 6. So the answer for this will be 6. Next, right to left. Towards left I have to go. Now I say p value is 108. That you should remember. I say asterisk p minus minus. So it is postfix decrement. So p value is 108. Decrementation will be done afterwards. Asterisk p minus minus means p is pointing to 108. Decrementation will be done afterwards. So it means to say, fetch the value of p. Take the value of p. P is how much? 108. Right. What is asterisk 108? Again the same value 6. Now, after printing the value, then it is going to do the decrementation. Then it will do the decrementation. So now p is pointing to 108. Do the decrementation means get backward by one element. So p minus minus is nothing but. So for this I'll get 6. Okay. Later p equal to p minus 1 means p is how much? 108 minus 1 into 2. So 108 minus 2, it will go to 106. So now p value is changed to 106. So now p is pointing to 106. So I have to change this now. So p is pointing to 106. Come to this. Okay. Asterisk p minus minus means it took the original value, that is 108. Value at 108 I got 6. Here also 6, here also 6. Then it will decrease means it will get backward by one element, one position. So 106. Now p value is 106. That you should remember. Now come to this point. Asterisk minus minus p. Minus minus. Again it is prefix decrement. Means p is pointing to 106. You decrement the value first and then you fetch the value. So p is pointing to 106. Decrease means here I have to do the decrementation first because it is prefix. So again it gets backward by one element. Now p, YOLO, p minus minus p is p equal to p minus 1. Again it is p is how much? It was 106 minus 1 into 2. So 106 minus 2, it is 104. So it is going to point to 104. So the new value for pointer is 104. So here it means to say asterisk 104. Value at 104, it is 3. So for this line, hope you have understood with this prefix and postfix, increment and decrement at one line. So when you have like this, the evaluation of the statement will be done from right to left, because we have the increment, decrement, prefix, postfix, and according to the precedence of the operators, the evaluation will be done from right to left. So the answer for this line will be 3, 6, 6 and 6. 3, 6 and 6. You can see the execution. Okay, so this is how we deal with pointer, increment and decrement. Now, what is the final value of p? It is 104. If I simply write printf percentage d asterisk p minus minus. I say printf percentage d asterisk p minus minus. This is quite different. Look at here. If I put the bracket like this, if you put the bracket like this, asterisk p minus minus, it is nothing but the same here itself, the same thing. Asterisk p minus minus is also same, written in brackets like this. Asterisk p minus minus also the same. But if you put the brackets for pointers like this, asterisk p minus minus, what will be the answer? So here the compiler will do in a different way. So bracket will be evaluated first. Asterisk p means what is the final value we got for p? It is 104. So what is the value at 104? It is 3. Minus minus means it is post decrement, right? It is going to print 3 only. If you write in a different, the answer for this will be 3 because it is post. The next line, if you write asterisk p, you will get 2. But you can apply the prefix decrement also. So here the answer for this line will be 3 only because it is postfix decrementation. So asterisk p means it will point to 104 location. Value at the location 104, it is 3, right? It will take that value and it has to decrease it. But as it is postfix, decrementation will be done afterwards. The next line, if I just say printf percentage d asterisk p. So p is pointing to 104. P value got decreased. The value gets changed. It becomes 2. This is what the answer for this. So hope you have understood how to use these brackets, how to use this increment and decrement operator. So let us see all these executions practically and we will understand how this increment and decrement operator is going to work.
So here we have the pointer incrementation program. So we have an array initialized with all these values and we have the pointer variable p and the address of the array is stored into p. So now what I'll do, I'll say print the value of p. Asterisk p means p is pointing to the first location, so it is printing 10. Then increase the pointer means increase by one location, that is one element, advance the pointer to the next location. So now it is pointing to 20. So if I just say print that asterisk p, it is going to print 20. Now look at here, we have the postfix incrementation. Postfix incrementation, right now pointer is pointing to this location, second element, right? So now I say asterisk p plus plus. So p plus plus means it will not do the incrementation. Postfix incrementation will do the incrementation afterwards. Fetch the value of p means p is pointing to the second location. So asterisk p means value at that location is 20. So here I'll get 10, here 20. For this I get 10 and for this I'll get 20, and for this also 20. Now, so now P is pointing to this location and I got the value. Postfix says you decrement later. So now the P gets advanced to the next location. Now if I just say asterisk P, it is going to print 3. So now the next statement I am doing, say right now the pointer will be to this location, the third element. Now I say printf %d asterisk plus plus p, that is prefix increment. Pre says you do the incrementation first and then fetch the value. So now p was here. Now I'll say you advance to the next location. So it will go to this next location. Then it is going to print the value -4. So let us see this. I just say save, Control F9. Now see 10, 20, 20, 3 and -4. This is how we can understand the pointer incrementation. So let us see the decrementation. So here we will see the pointer decrementation. The same thing, we have the array and we'll say p equal to a. Now I'll say printf %d asterisk p minus minus. So as p is pointing to the first location, first element. Okay. Now I say asterisk p minus minus. Just observe it is p minus minus. So it is postfix decrement. Postfix decrement says you do the decrementation afterwards. But you fetch the value that what you have in p. P is pointing to the first location. So when I say asterisk p minus minus, p will be pointing to first location. I am going to get 10. Then later the decrementation will be done. So p will be just moving backward by one location. So when I get backward, there is nothing here. So of course memory will be there, but you will get junk value. So in the next line, when I say asterisk p, p will be having the previous address. That is, it will go backward by one position. So it will be pointing to the previous, that is beyond this. Then there is nothing to print there. You will get a junk value. So let us see that now. Save this, say Control F9. See here, first one is 10 and then decrementation, it is going backward location. So I got a junk value which is 856. Okay, so now what we'll do, instead of going backward from the first position, let us take the address of in between element. So I'll say pointer p, I say p equal to ampersand of a of 3, that is 0, 1, 2, 3. That is the fourth element address I am storing into p. Now when I say asterisk p, obviously it is going to print -4. The next line what I'll do, I'll say asterisk minus minus p. It means to say it is prefix decrement. So it has to decrement first and then it has to go to that location. So p is pointing to this fourth element location. Now it has to get backward by one element, means it will come to this point and print that value, means it is going to print 3. First it will print -4 and then it will print 3. So we'll see the output now. Let us save this. Control F9. See, -4 and then 3. Let us have a complex statement now. So let us have printf. I'll say let the address be to the a of 3 itself. Now I'll say %d, %d, %d. Now I'll say asterisk minus minus p, comma, asterisk p minus minus, comma, asterisk plus plus p. So let us see the output now. So here it is going to evaluate from right to left. As I said, I have explained. So it is going to say asterisk plus plus p, then asterisk p minus minus, and then asterisk minus minus p. So what will be the output? I have explained to you in the dry run of the program. Let us save this. What will be the output? Look at it. It is 3, 6, 6. So as I said, it is 3, 6, 6. So here what happens? It is going to consider this asterisk plus plus p. So p is pointing to the address of a of 3. That is the fourth element. So as it is prefix increment, it is going to increment first. Then it is going to access that value. So I got 6. Then what I'll say? Asterisk p minus minus. So this asterisk p minus minus is postfix decrement. So it is going to take the p value first. So p is pointing to this location. So it is going to print that. So it is going to get 6. Then it gets decremented. So p will come to this position. backward by one position. Now I'll say asterisk minus minus p. So here minus minus p means it is prefix decrement. So here it is p is pointing to this location. Now decrease means again get backward by one more location. So it will point to this 3. So my answer is 3, 6, 6. That is what I got. Look at the output screen. So it is 3, 6, 6. So hope you have understood with this prefix increment and decrement. That's all for today's video. See you in the next video. Till then, take care. Bye bye.